here, because it's like going to a state-of-the-art presentations of robotics today. So I hope I'll be happy with the standards of the speakers before me. First of all, what I want to tell you is that what you are going to hear is a very biased view, because I mean, as somehow as Tamim has said before, we are very much interested in studying humans using robots. So that's our main. So the three keywords. So one is anthropomorphism, similar to humans in many senses. One is engineering based, to use engineering as a tool to test theories, but also to somehow to consolidate knowledge, to put knowledge into the system. And last but not least, interested in systems which become intelligent. So this idea of developmental robotics we have been working on for many years. So the natural framework is the study of social interaction. Studying humans and robots and investigating them together. So that was the motivation for the ICAB project and for many projects before that. So social robotics. So if we speak about society, of course you have to take into consideration what I call this ethical dilemma, which was very well summarized in this book by Norbert Wiener, whom I'm sure you know was the father of cybernetics, who wrote this sentence: the mechanical brain and similar machine can destroy human values or enable us to realize them as never before. So it's always a struggle when you think about and you speak about society and robots, and one of the reasons is also because everybody, or almost everybody, a lot of people have read this Asimov book, and they know about this robotics law and they take them for real. So society, in fact, expects the robots going out there to work with them to be able to respect at least the first law, which is basically the essence of intelligence, being able to predict the actions, the effect of your own actions and the effect of the actions of others. So, and along this stream of research, we have been working, we have been listening already about, human-centered approach to robotics. So we work on robots that will be able to assist elderly and help children and so on and so forth. I think we have to be very careful here. We have to be very fair to society about the claims we made in order to avoid promising abilities which are there in the future and are good to track, but they are still far. In fact, somehow reading papers, it looks like we are close to delivery, these autonomous cars or personal robots. You see video clips like this one where you give the impression that the robot is understanding something, what is going on around it. And we all know that this is not true. This is a very well engineered video clip that shows things which are not true. So what is the issue here? Why it's so difficult? Well, certainly one of the problems is that there is a mismatch between physical abilities and interaction skills. I won't tell you anything. Well, okay, anyway, that's fine. Yeah. Well, it was a real pleasure. Thank you very much. So there is a mismatch between these physical abilities. Everybody remembers. Maybe people wise males remember these very old video clips from Mark Reigert with the hopping device. And a lot has been going on. Everybody knows about what Atlas can do now. But on the other hand, we are still stuck with more or less remote control devices. It's still there. We are using a language which is not ours. It's the language of technology so we are still far from this idea of a symbiotic, I call it humane interaction. This idea. We are basically stuck with humans using robots or robots using humans somehow. Why? I think there is space for a complementarity between human and robot somehow, and then which is the degree of complementarity is up to now to us to try to find out. It's not impossible to think about a symbiotic relationship where the humans does one part and the robot does another part. So the target somehow is what I call more humane robots, and starting from this observation, this statement that Italo Calvino did a few years ago, which says that our imagination cannot be anything but anthropomorphic. Thanks a lot. Yes. Well, it's going to be difficult, but anyway, is anything but anthropomorphic. So trying to make a system, an artificial system more human, and a humane robot is not necessarily a humanoid, but it's something that stimulates this anthropomorphic imagination that Calvino was referring to. So Wall-E is a humane robot, and it's machines without manual. This is how I call these machines with natural kind of interaction. So how come we don't have these devices with us? I mean, the very simple issue is that the problem is not acting, but understanding. So it's not making a robot able to move like a human, but it's making a robot able to understand what the others are doing around him. And then how can we, this is very much limited things, so how can we make a step forward? I think we need to make explicit, the relationship between the body of the actor and the mind of the observer. That's the issue of interaction, basically, and vice versa, of course. It's a mutual relationship. It's not a one-direction relationship. So, talking about robots, I think we need to start exploiting the body not only to execute actions, but also to communicate the intentions, to communicate the goals of the actions and the values that are going on, somehow to become a predictable machine. So this is a communication channel is what human-robot interaction is about. And certainly, it's clear that it is much more difficult to understand the messages embedded in actions than execute actions. And these messages embedded in the body of the robot are very rich. There are a lot, from gaze to hand movement to facial expression to posture, distance, appearance, and then, all the touch, force-related things or the auditory channels. All of them are motor, and somehow related to movement. Some of them are explicit, like, coming here or go away or making, this kind of signature. But some of them are implicit, and these are very interesting because they are implicit in the body. The fact that my visual system has a fovea forces me to move the eyes around. And this is something which is exploited to exchange messages. Or the way I gesticulate, in Italian I gesticulate very much, but there are laws which control the velocity of my movements with the curvature of the trajectory. And these are embedded in the body, that there are properties of the muscles, properties of our sensory system, and are there to be exploited. So I think in this respect, we need to address these dual aspects of anthropomorphism. One is the body, which is there, you can touch, you can work on that. It is certainly an important part. But there is the anthropomorphism of the mind, which I think, the extreme situation is to be able to think like a human, but there are intermediate steps. Somehow be able to relate with a body, with a human-like, with a sort of a human-like body. So we need to harmonize this. We have robots with a very nice anthropomorphic body that can jump and do a lot of things. So they pass the messages that they have an anthropomorphic mind, while they don't. So, in fact, a robot does not need an anthropomorphic body, to act on objects. You can have grippers made of coffee bean and just some box, some sacks. But certainly, you need an anthropomorphic mind if you want to imagine the affordances of objects, if you want to give a meaning to a chair, a chair is not a shape, is not an object, is an action for us. So this is the essence of embodiment, You have to reason about this. And if you go, going about social interaction, of course you need an anthropomorphic mind to give a meaning to a human, What is a human? A human is something like me, so it's a relationship. It is something I can relate to, and so there is a direct mapping between my body and the body of someone else. So the main obstacle is not to build robots able to move like a human, but to embed the models of humans in the robot, to be able to understand. And this applies not only to humanoids, applies to cars. An autonomous cars has to understand what the other drivers and what the pedestrians or the cyclists are doing. So I claim that there is, in this sense, there is no safety, about about robots without this kind of movement. So, in some sense, we need to define the minimum quantity of anthropomorphism, necessary to stimulate our anthropomorphic imagination. What is the minimum? Of course, the more the anthropomorphism, the more the potential richness of the messages you can pass. But I think would be very glad, if we can find what is a minimum quantity. For personal use, I may add, if I can extrapolate. So WALL-E is a minimalistic human body, and it has been carefully designed to have eyes and hands, this sort of anthropomorphic kind of things. And of course, you also need to study something which is even more difficult to me to understand, which is the relationship between the physical part of the body and how the body moves, and the fact that the relationship has a social meaning. This uncanny valley here is most of the time, to me, generated by the fact that there is a discrepancy between the way the robot looks and the way the robot moves. So, what's the way? Well, of course, it's a long and winding road. We see some of these. We don't see all the road. We know where we want to go. But the first step we need to take, I think, is to go beyond purely reactive systems. We have this fantastic demonstration that was made by the group of Francesco Nori, who is sitting over there in Geneva. So it's this, let's say, classical, very important, very interesting, essential, fundamental action perception loop. But I think we need to go a little bit further. And I have another examples here. So you see, you have a baby here and the eye come reaching for a red object. First thing you notice that they seem you tend to attribute the same level of intelligence, but the girl here is transmitting the fact that she wants to reach for the object, while so this is just a reactive kind of behavior, and the fact that it is not a reactive kind of behavior is very clear here in this other video clip where the object is moved. Keep attention to that. Tack. Okay, you see, the action of the baby was anticipating. So we need to go out of these things somehow, we need to add intentions. We have heard about that, and the experience, the learning that Jan Peters was talking about. And you end up with a different loop, which I think is what we should maybe go toward, this exploration prediction loop, which somehow allows us to predict the future. So as Alain Berthoz put it a few years ago, so we can beat flesh by trying to be predictive somehow. So this, I think, is important, and it is important to reason why we are able to do that. We are able to do that because we can imagine our actions, and we are able to act prospectively in this sense. So we don't act here. This first law of robotics basically is that kind of things. Being able to look ahead. So. One of the central topics of robotics research is the study of the role of internal models. this is what we miss very much. And in the past, Wolpert was proposing the forward model for motor control. Marc Jeanneret and this mental simulation theory was a milestone in this respect. So we need to think about how to put models of humans inside a robot in order to be able for the robot to act prospectively. And I'm basically trying to convince you that you need to have a humanoid robot to study these kind of things. If you want to close this loop, use robots to understand humans to build robots, you have to use humanoids robots. Of course, you have to use humanoid robots in the same way you use a wind tunnel to study the interaction of a shape with aerodynamics. So you can use that as a wind tunnel and then end up working on different embodiments. So this is what we are doing. I'm not going to go into any details of what we do, but basically we put the robot in a loop of interaction, and we can move it in a very controlled way to understand which are the parameters of the motion which convey messages. For example, how you can pass the weight of an object by modulating the velocity profile, or what is the relationship between curvature and acceleration, and acceleration when I move my hand. And all these are conveying messages. And we can demonstrate that these can build up more efficient robots. So this loop, study human internal models to build better robots. Yes. The last few slides I want to spend, this is a new place that is starting. So I need, what I want to pass is a message more general. In order to advance knowledge, we need to go a little bit further with respect to this idea of interdisciplinarity, where you basically engineers read a paper and builds a piece of robots. We need to put the two communities much closer to each other. We need to establish a real link, and do joint experiments. Some of the things I was referring before are joint experiments we do with psychologists and the neuroscientists, because we want to go from describing what a machine is doing, which can help in building up a biomimetic system. We wanted to use robots also to explain, the principles, something that was mentioned before. What it means to be human is there. And then you may end up with robots which are not anthropomorphic at all. If you find the principle, you may not need to do that. But certainly what I want to stress again is that the evolution of social robotics is bounded by our lack of knowledge about the human mind. No, this is something, we know what the robot is, but the robot doesn't know what we are, And if there is no model, there is no social life. So, let me spend the last 2 minutes by saying that we have to be fair to society, and declare that we have this lack of knowledge. We need to extend this knowledge. How? Well, maybe a place like this, the one that is starting now, joining forces, and then everybody has to do his share of effort there. Companies need to build, in my view, needs to be a better internal culture about interacting with humans. The principles, Asimov had this Susan Calvin robot psychologist in the team. I think industries should think about that. Policymakers need to take decisions based on facts and objectives, and not on emotive bubbles, or superficial belief, because explosion of activities in one area, it's fine, but you have to balance that with and then think about what is really necessary. Publishers needs to be convergent, in 2017, Nature had this very nice special issue about interdisciplinarity, and then, soon after, 4 new nature journals came out, just to split the field, you know. We have Science Robotics, very nice, excellent journal, very good editorial board, all of them are friends, but did we need that or not? I don't know, I don't think so. I mean, but also from the academic point of view, we have to be much more open than what we are. You know, we need to really open up to social science, humanities, hard, you know, to understand what is the role of the human body there. So we need to invest in establishing, you know, environments, maybe like this one. You know, the coffee machine, when I was in young people say, well, the coffee machine is where people exchange ideas. It's not enough now. You know, people have to do much better. And altogether, we need to educate the society about what can be done and what cannot be done. You know, reading sentences like in 15 years truck drivers will not be there, or that, you know, walking again is around the corner for people who have a broken spine, and then all other things. So we need to be very clear about that, because we need to all together, you know, decide what kind of society we want. In the future, you know, what kind of coexistence with robots we need to have. And I mean, this is a fantastic community, but we need to enlarge that. We need to really work together with others. And with this, I thank you very much, and many successes to the new center that just started. Thank you very much.